Hello, today we want to give you a few ideas on Circle Theorem. We solving problem using Circle Theorem, so today we want to give you a small idea on it. Basically, we want to use two to start from that point. We'll have more videos to come out on it. So here, quickly, the two, let's look at the first one, and number one here. I want to look at the theorem I'm talking about, is secant and tangent. Secant and tangent line theorem. So secant and tangent line theorem, how does the diagram appear? This is a circle, alright? What will happen? We have this line, we have the line of this form. So let's say this is A, B, C, and this is maybe Q, D, right? Which one is the secant and which one is the tangent? From Q to C is the tangent because tangent is the line that touch the circle to one end. So this is the tangent. And then the secant is the line that intercept or touch the circle to two ends. So here and here is what I make from line A to C to E, what the secant. So automatically, this is how the diagram appears for a secant and a tangent line theorem. So when this happens, what the tangent and the secant line theorem says? It says the square of the tangent line is equal to the product of the secant lines. So let's look at this Q to C. QC. The square of it will be equal to the product, meaning AC times BC. Alright? This is it. So anytime you have problem of this nature, they ask you to find the value of A, you work with this one. So let's try something quickly, right? So this is number one. I think we're going to be doing two. So quickly we can try maybe 2 here, we can try 2 meter here, maybe we can try 3 x meter, maybe you can just try x meter right here. Yeah, then they ask you, maybe they say find the value of x. So to find the value of x in the case, just how we say the square of the secant line. So D or Q to C here is actually x. So from this point, I can just put x meter here and I square it equal to AC. A to C is the combination of 2 meter and 3x meter. So I will say 2 meter plus 3x meter. It closes time BC added 3x meter. So if I do this, we know that will be x squared meter squared equal to 3x meter times 2. And my will be 6 x meter squared. 3x meter times 3x meter. We get plus 9 3x squared meter squared. Alright? From this point, this is what we will have. So we have this is x and this is x squared. And you have x squared. So I will bring this up. I will have x squared meter. Also, let me transpose it, right? Let me send this man on this out to that. So when I will have negative 6 meter equal to 9x squared minus x meter squared. We go over and have meter squared here. So from this point, I will have negative 6x meter equal to, we have positive 8x squared meter squared. So meter squared here. We go from here to come here. So from this diagram, we see clearly that x and x is here, but this is x squared and this is x. So if I transport this man back here, I will certainly have 8x squared, follow me, 8x squared meter squared, and then we'll come back with down positive. If I send it back, positive 6x meter squared, all equal to 0. If you remove this man from right here, equal to 0. I just state the equation in terms of the left hand side, right? It was left and right, I just state in terms of the right hand side, and normally to have this form. If this is the way, we see that this and this have something in common. They have x and x, and we also in terms of the coefficient 6 and 8, we can factor something out. So let's do it quickly. So we don't want to find x value. So I'll put x here because this is a quadratic square. This is a quadratic. I'll put x outside here. When I put x outside, then 6 and 4. What comes to them? And where are 2? 2 is common to go over. So I'll put 2 out here. Then I'll put 4x inside here. You put 4x in here. 2 down 4 again. 8. 2 down 8. 2 down 4 again. 8. X down here will be x squared. Now I put plus here. I put 3 in there. 3 meter. And then here I'll also be meter. And here I'll also put 3x meter here. Now, equal to 0. So I will take the product out. So when I do this here, you see, when there are 2 ways here, there are 4 ways you can solve quadratic equation. Factorization, by completing the square, by using the equation, and also by graphical method. So this is the factorization. To find the first x value, I'll tell you x, I will take the 2x. 2x will be equal to 0. So when I divide both sides by 2 here, 2, the first x will be equal to 0 meter. Then find the second one. I will take 4x meter plus 3 meter equal to 0. So I want to find x. So I'll keep the 4x on the side meter. I'll say this here we have negative x as negative meter. Negative 3 meter. And divide both by 4. Divide both by 4. And I then level x. This x will be equal to negative 3 up over 4. Alright? I know this is how it might appear. So in this case, if I say we found a positive value here, it means that we'll take 0. Even though 0 is not a positive or not a negative number, but just 0. But if they ask us, I just give an example, right? If they ask us to find a diagram that here that says to find it, this is how you work it out. And I know if it were a standard art test, you know the question will be unique in the way that you work with your good value. But just in case when the problem here, this is how you work with it. So this is how you work with the secant and the tangent line. So quickly let's get number 2. This number 2 here, of course, we see it is all about the secant lines. So we need 2 secant lines, right? Secant lines. I put S to it. So when we say the secant lines have the diagram appear for this field. The diagram appear like this. If this is a circle, you will see something like this. And you also see another secant line intercepting. I know you will see something like that in a test or places that you've been doing tests there. You'll see something like this. So there's a diagram appear like this. This diagram and that diagram they are not the same. Get it clear? Here we have 2 secant lines. So from that point we say A to B is a secant line, D to B is also a secant line. So why we call it secant line? From the first one I told you, the intercept is circle to 2 places. So it means that they are secant line. Wait, how do we solve problem here? It says we take the product of the 2 secant lines equivalent to one another. The product of the 2 secant lines is equivalent to one another. That is why the secant line 0, 0. So we say A to C, AC times C to B, C B will be equal to D to E, D to E times D E to B, E to B. This is how you work it out. So from this point, you can try something, right? That's enough. Let's go Y here, we'll go 4, go 3, go maybe 2 here. Yes. Then they say find the value of Y. In the case, we know very well that A to B, A to C is 4. So we'll go 4 there times. We know C to B is 3 times 3. Will be equal to, we know from D to E is 2 times. From E to B is Y. Y. So automatically we have 12, 3 times, or 4 times 3 is 12. We get 2Y. So divide both sides by 2, divide both sides by 2. And you have 2 and divide by 2, it gives 6 equal to Y, or Y is equal to 6. So this is how you work with a diagram that here to the form. So thank you. Continue to follow for more videos on Circle Theorems. Thank you.